Okay, this is a Gauteng province question from June 2017, question 9. Aluminium sulfate, also known as dialuminium trisulfate, is an aluminium salt used in the textile industry and also in the process of water purification. It's a white solid when it's not in contact with water. Now it says to you, how many oxygen atoms are present in 12 grams of aluminium sulfate? And this is 6 marks, so you know we're not just going to whip the answer up in 2 seconds. So the first thing we have to do is, nowhere in this question does it actually give you the chemical formula of aluminium sulfate. Okay, so you need to know from your brain or from the periodic table that aluminium forms 3+ ions and sulfate is a diatomic ion with a charge of 2-. So if you've been listening in class, you know that everything must be neutral. So this, we are going to have to, in order to neutralize this, we need the 2 negative and the 3 positive. Everything must be neutral. We bring down whatever the charge was here and make it the subscript, and we take down that one and put it over there. So this, in actual fact, is the formula for aluminium sulfate, Al2SO4 But if you didn't know this, if you look here at the question, it says dialuminium trisulfate. So di means 2 and tri means 3. So long as you know what a sulfate ion looks like, you could figure out that this is aluminium sulfate, Al2SO4 Okay. So it says to you, how many oxygen atoms are present in 12 grams of aluminium sulfate? So either way, the first thing we always do when we get anything like this is we have to find the moles. So even if you weren't sure what to do, the first thing we can do is we can find the moles. And so in order to find the moles, we're going to say that the number of moles of aluminium sulfate, okay, which is a nuisance formula to write. The number of moles of aluminium sulfate is going to be the mass over the relative molecular mass, which is going to be 12 from the question. And then let's work this out over here. What is the aluminium sulfate mass? Okay, the relative molecular mass. Aluminium is 27, and there are 2 of them, so that's 54. There are, because this whole sulfate ion is in brackets and there are 3 of them, there are 3 sulfur atoms, so that's 3 times 32. And if we have a look here, the SO4, each SO4 has got 4 oxygen atoms, and we've got 4 of these sulfate ions. So we've actually got 12 oxygen atoms weighing in at 16 each. So this aluminium sulfate is 342 grams per mole, which is actually quite heavy. So we're going to come here and put the 342 grams per mole in. And if you plug this into your calculator, you get something like 0.035 moles. Now that is the moles of aluminium sulfate altogether, okay? But it asks you how many oxygen atoms are present. So the formula that links atoms to moles is N equals N over Na, where Na is Avogadro's number. Okay, so we don't use this formula a heck of a lot, and I've never seen it used in grade 12, but you need to know about Avogadro's number. So the trick here is you actually need to realize that in 1 mole of aluminium sulfate, we are going to use the mole ratio again. Okay, you need to know that in 1 mole of aluminium sulfate, there are how many moles of oxygen atoms? And it is 4 per sulfate ion, and there are 3 sulfate ions, so it is 12 moles of oxygen atoms. In the same way, we could say that 1 mole of aluminium sulfate gives you 2 moles of aluminium atoms, because that's the subscript there, and it gives you 3 moles of sulfur atoms. But altogether there are 12 moles of oxygen atoms. So from here, when we worked out how many moles of aluminium sulfate we had, we know that there were 0,035 moles, and that is now going to give me 12 times 0,035 moles. Whoops, and I should not say, yes, it is correct to say it's the moles of oxygen atoms. So it's 12,035 moles of oxygen atoms. Okay, so this works out to be 0,421. So if we had to split aluminium sulfate up, this aluminium sulfate actually contains 2 aluminium atoms, 3 sulfur atoms, that's 5 atoms, plus 12, 17 atoms altogether in this one single molecule. So it's quite a complicated ionic salt. But what we're interested in now is this 0,421 of oxygen atoms, and we're going to put this into Avogadro's number formula. So N is going to be 0,421 times 6,02 times 10 to the 23. Remember, we get Avogadro's number off the data sheet if we can't remember it. So we get 2,53 times 10 to the 23 atoms. So remember, you need to understand your definition of what's a molecule, what's a compound, what's an atom, and then it's quite easy to realize 12 oxygen atoms per molecule of ionic molecule. It's not a molecule, it's an ionic formula unit of aluminium sulfate. Okay, now let's look at 9.2. Let's do this in a different color. 9.2. Prove that the empirical formula of aluminium sulfide, notice that this is sulfide, not sulfate. Prove that the empirical formula of aluminium sulfide is Al2S3 using the following information. 36% of aluminium sulfide by mass is made up of aluminium. So if 36% is aluminium, 100 minus 36 is going to give us 64% is the sulfur. So in any empirical formula calculation, what do? We say that we assume we have 100 grams. Okay, so then we say the ratio of aluminium to sulfur by mass is going to be 36 grams, and this is going to be 64 grams. So now we need to find the moles, and we do this using N equals N over M, so we can write it on the side here, N equals M over big M. So this is going to be 36 over the big M for aluminium is 54, and sulfur is 32, so this is 64 over 32. And if we put this into our calculator, we get 1.3 is to 2. And then the moment we do a calculation like this, we have to divide by the smallest. So 1.3 divided by 1.3 is 1. Okay, divide by the smallest. You understand this is to simplify the ratio. And then 2 divided by 1.3 gives us 1.5. So now usually with a mole ratio here, what happens is that we get 1,01, 0,99. But if we get something that is so clearly here like this, a half, we may not round the half. What happens is if there's exactly a half, we have to multiply everything by 2. And this gives me 2 is to 3. And therefore we can say that the ratio, the empirical formula, is exactly what was given here in the question, Al2S3, because anything that comes out to exactly a half, you have to multiply by 2. This often happens with the dichromate ion. They like to give you ammonium dichromate or something, and that's Cr2O7, and then you end up with 1 is to 3.5, and then you multiply everything by 2 to get to whole numbers. You may not round them when they are exactly a half. Okay, So then we have proved this part, and then the last part says that we need to rewrite the following equation. The hydrolysis, which is a reaction with water, the hydrolysis reaction of aluminium sulfate generates gaseous hydrogen sulfide. This is a horrendous gas. It smells like rotten eggs and is very dangerous, so we should not be doing this in the lab. Rewrite the following equation and balance it. So we have H2O plus Al2S3, and this is going to hydrogen sulfide, smelly rotten eggs, plus AlOH3. So you can't see that 3, pretend you can see that 3. It should look beautiful there. Okay, so the thing here, that the first thing that I look at if I look at this equation, or if we look down here, is I've got 2 aluminiums on this side and only 1 on the other side. So I'm immediately going to put a 2 in there to balance my aluminiums, because the aluminiums are not really, it's usually easier to fiddle last with the oxygen and the hydrogen, and fiddle first with the metal atoms, because it just works out easier. So I fiddled here and I've balanced my aluminiums, and now if I look, I've got 3 sulfurs here and I've only got 1 on the right, so I'm going to put a 3 here. So I've now sorted out my metal ions and everything that went with the metal ions, because that's usually the easiest. So if I now start looking, I can fiddle with the water here. Okay, so altogether here, my 3 sulfur, 2 aluminiums, that's fine. But now if I count here, I've got 6 hydrogens here, and I've got also 6 hydrogens over here, because this is 3 hydroxide ions. So if I've got 6 hydrogens and 6 hydrogens, that's 12 hydrogens, which means I need something like 6 water, which has now given me, when I put the 6 here, it's given me 6 oxygen atoms. So this is AlOH3. This 3 is really terrible here. I'm sorry you can't see it. But if there's 3 oxygens for these hydroxide ions, and I've got 2 molecules, I've got 6 altogether. So I do believe this is balanced with the 6 and a 3 and a 2 over here. And there we are finished, and the equation is balanced.